Welcome back again. We're starting the second part of our assignment video demonstrations. And so as we start this next piece of the assignment, I think it's important to understand that we are transitioning from orthographic to paraline. The orthographic projections were pretty simple, and they represented component pieces, top view, front view, side view. And they will then become what we will learn later as a multi-view drawing, which most orthographic projections are. Now we're moving into paraline drawings, and these paraline drawings represent three-dimensional views of an object. That means that we're seeing simultaneous views of the front, side, and top in different relationships. So as we do this, it's important to understand that there's a significant amount of distortion that occurs. The lovely thing about the orthographic projections is that they stay pretty true to scale and to performance all the way through the process. And this is why architects and designers use these drawings in their contract documents. These other drawings are more analytical and they show more elements put together so that the observer can see the different parts and how they work. So in our very first a paraline drawing, we are going to be doing an isometric. Now, isometrics aren't done that often in designers' offices. In our next activity, we'll look at a plan oblique, and that's more regular. But for this exercise, I think it's good to understand how isometrics operate and how they work. And for purposes of this exercise, this drawing right here that we referred to previously is an isometric. And so it's going to follow a few rules that you need to understand in order to be consistent in how you draw the drawing. So the first thing you need to know, and a rule for all three of these paralines, is that vertical lines will always remain vertical. Horizontal lines, which are represented here, will vary by drawing type. And so in this drawing type, the isometric, we're working with a 30-degree angle off horizontal. And so we're going to look at using a different triangle. We're not going to use the 45-degree triangle. We're going to use the 30, 60, 90 triangle. And this will give us what we need. Now, what you need to understand is that this angle, if we use the drawing and look at it from the standpoint of what's provided here, this horizontal line is what is true to our orientation. And that 30-degree angle is going to be very important for every placement of those horizontal lines. Now, whether we place and draw them at this angle or we flip it and draw it at this angle, still 30 degrees. That 30 degrees will not change this way or this way. And so you can see that flipping will provide us with what we need. So as we look at this element here, we're going to see that this line here, 30 degrees. But when we come to its 90-degree counterpart, it's going to line up with this piece. And then again with this piece. And then again with this piece right here. And so on. So as a result, this angular change will always be based on the 30 degree for isometrics only. Isometrics only. Other drawings will be different, and we'll look at those in just a minute, or as we get into the next assignment videos. So in this particular case, this one works. Now, because I happen to be a fan of the adjustable, I've adjusted the triangle to be a 30, 60, 90. That means this is 60 and this is 30 and that's 90. So this works good for me. You can use this if you do not have this. And you'll see the same concepts. We're just going this way and this way. in terms of our angle projections. So, having said that, all these next three drawings are all predicated on the idea that we start with the floor plan or the floor orientation first. And if you look here, that means we're not looking at the top piece of this so much, although the top view of it gives us a really good idea of what things are doing, and we can place that using that view. But as we look at this, and this is very close to the assignment we're working with, so you can, in this first exercise, rely pretty heavily on this information because this is an isometric. So as we move forward, I want to point out that we can use the orthographic projections. I'm going to keep this drawing available to look at, but it is not necessarily the main guide. In fact, I'm going to set it over here because my drawing's already populated on that side. So as we look at this, we're going to see that we're going to focus our attention on the top view, the plan view first, and that's going to give us the information we need. So that requires that we do our measure and mark and use our triangle to place the angles as we're going. So I'm going to just start, and you're going to see how this works. So the first thing is I've located the drawing area up here. This is the top corner. Again, this is a rough out. You're going to have to finalize your drawing as a finished drawing, probably with another sheet on top, and you shift it around to make sure that the placement of all these drawings is correct for your finished drawing. So I'm just going to do the rough in here. You can do the finished work on your own. All right, so having said that, we're going to, and again, you can see I'm starting up here in this corner with the isometric. So I'm keeping true to the example that's provided. So having said that, I'm going to go ahead and set my parallel. I have already moved the sheet around so it's comfortable for me right here. I've trued it. I've set the sheet true to the parallel, so everything is good. These drawings are still square. Everything's good. Okay, so if you move the sheet, you've got to resquare it. Every time you touch the sheet, you got to resquare it to the parallel or to the T-square. All right, so having said that, I'm working in this area. I'm just going to give myself a reference line horizontally, and it's going to be kind of light. And by doing that, now I know everything is going to be based upon this point. Now, we have if I'm using the diagram here, this corner right here is this corner right here. So looking at this corner, I can interpret what that plan is going to do. So I'm going to create a profile. Just remember, 30 degrees, not 90. Okay, so based on that, I know that that angle from this point going this way is 30 degrees. So here's my 30 degrees. I'm just going to set that up here and just draw some length. Okay, and I'm going to flip the drawing or flip the triangle and go this way. So again, if you're using this triangle, you can see it. There's that angle. And by the way, if you're drawing this way, you can see it's a little easier. There's that angle. And there's that angle. Again, flip-flop, flip-flop. Okay, so I'm going to return to my triangle here, my tool of preference. And so I have identified this corner, which is right here. Now, I'm going to start by going back the distance, and that says it's 6. And I can measure it here if I want. There it's 6. There it's 6. So, measure and mark 6. The next dimension, see, I'm just going to start here and go all the way around this thing to create that profile, that plan profile. So next I'm going to come over here and I'm going to mark it, the the next corner, which is here, and then here, then here. You can see the sequence. So the next one is 2 also. Is 2 in the first case, and then we're going to do 2 again. So that moves to there. Erase the tail, and erase that tail too. Okay, now that distance right there, 2. So I'm going to flip my triangle, and look, it brought me back to the horizon line, or not horizon line, it's just my horizontal line. Okay, and if you look at the example, pretty much happening there again in the example. So now I'm going to, and I should measure that, it should be 2. Indeed it is. So I'm going to continue on. Now I'm going to be drawing, I've drawn this line, this line, this line. Now I'm going to draw this line. Again, 30 degrees. So using my triangle, setting it, and going up at a 30-degree angle. How far? We're going measured from here, 4 units, same as over here. Everything's the same, so we just measure, and we do the 4. Mark it, draw it. Now, it gets a little funny now. We're going to flip around to the back side. Not everything is viewable from here, but everything's easy to see from here. So we can follow this drawing because it is correct. So, how far back? We've drawn here, 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 come across the front, and that's where we're at right now. Now we have to get this side. So we have to backtrack a little bit going the 30 degrees, and you'll see how that works. If I was drawing this using this tool, this triangle here, I would now be back to the 30 degrees, but I'm going to go back this way now. Okay, so I'm going to come, because it is turning back on itself, we've come this way, this way. Now we're actually coming up to plan this way, and we're going to do the same thing here in a minute. So you're going to see these angles change up a little bit. And what happens is, again, because it's a 3-dimensional representation, certain distortions occur. We can't see that in this part of the drawing. We can, because it's hidden by the other elements that are drawn there in that 3-dimensional view. So we've drawn the front, now we're going to draw the back, or this part that we don't see. So how far back? It goes 2. We measure and we mark it. Now we're going to test a little bit here. That lines up across here, doesn't it? From this side to this side, it's the same. Remember, it's symmetric. Watch what happens when I line up, same point. So I want you to start understanding some geometry that's occurring here. The things that aligned here are still going to align there. It's just going to be on a funny little angle, that's all. Okay, how far? 2. So we come back over here, mark it, and extend it. Okay, so now we've got the front angles squared away. We've got this line here, 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 which is right here. You can't see it because it's hidden, is right there. Now we're going to turn the corner and bring it on home. So we know that we've gone 2 dimensions over, 2 units over, and so we should be good. So now that extent, remember it's symmetric. If that is 6, that's 6. So we measure and we mark. And we draw that. Now, remember how we tested this side right here by saying it aligns? Let's check the back side. Oh, look at that. That line connects in with that one, again, on the 30 degree. So 30, 30, oh, these are all 30 degrees, off horizontal. So that is the floor boundaries of this object, taken in isometric using a 30-degree angle, base angle, off the horizontal. So now that we have the plan, we can now start to project upward to create the form. So this is one plane, and this drawing that we have here is our starting point. Now, our next point in this process is to remember how tall are the walls. From when we looked over here, we observed the walls as being 3 units high. Every wall, every single wall was 3 units high. This one, this one, this one, this one. This one, this one, this one. They're all 3 units high. Now, I want you to draw 3 units high on every corner of this base plan. So, I'm going to measure and I'm going to mark. Now, generally speaking, you can mark each one, and it's probably a good idea initially to do that so that you kind of know if you're in the right neighborhood for these forms. But we're going to continue to mark each corner, and we're going to measure up 3 units from each point. This corner, every corner, 3 units up. So we come over to here, go 3. Oh, we got this corner back here. We got to get this one. 3. And then we got this corner here, 3 units again. Every corner goes up 3. Every corner goes up 3. Okay, I've done every single corner. Now we're going to project a line up. Kind of go light at first. We'll burn them in later. So we're just going to go up to 3, all the way around. And we're going to connect some dots here in just a bit. Okay, so vertical, vertical, all these have verticals all the way around. This one has kind of a funny duplicate vertical, so we have this vertical overlapping this one. Don't worry about it, it's okay. It's part of the 3-dimensional distortions that happen. But all the rest seem pretty logical. Now, we're going to connect all those the tops of all those lines together, and we're going to start seeing a form develop. All right, so following along, just go from point A to point B. Again, use the right angle. It is the correct 30-degree offset that we're using, and they should all line up. Okay, so as we do this, hopefully you're starting to see this 3-dimensional form start to develop. Okay, now you got to be a little cautious with some of this because you're going to start to see the light guidelines that you've created can start to create some visual confusion. You want to be a little bit careful with that. So in light of that, I would keep the light lines, the ones that you used as guides, keep them light so that you can erase them later. The lines that are prevalent that you see here will be the lines that we want to draw to. Okay, so now we've got the base walls all the way up, all the way around this. The thing we have to start doing now is making sure that all these angle lines start working. And again, 3-dimensional lines or 3-dimensional objects, when drawn, will show some distortion. So you're not going to get the true 45-degree angle here anymore. It's going to be kind of a connect the dots kind of scenario. So in order to do that, we're going to project up, given the information that we have here and here, and using the axial lines of the ridges here, and the points of connection will should come through pretty easily, and you'll see how they work here. So as a result, referring back to here and to here, we know that at the side view of this, let's start with this point, that this was in the middle, and we could project up 45 degrees to make that work. We can't do the 45 anymore, but we can still project to the middle. So, having said that, we're going to come to the middle of this drawing right here, and we know that it's 6, and the center point's going to give us 3 on one side and 3 on the other. So we're simply going to mark the point where it's in the middle, that 3-unit measurement. And we're going to extend it up. How far are we going to go up? It says 6 units. We can measure, We can measure here and we can get it because that's 6 units up, or we can follow this diagram. Doesn't matter, they're both the same. So I'm going to measure up vertically. Remember, vertical, stay vertical. And that's going to give us a point right almost on top of that back line there. So don't worry about it. Again, it's going to be kind of funny later on. So we're going to do the same thing on the back side. This line across here, which is hidden here, but is symmetric on this thing, on this element here, we can do the same thing. So I'm going to measure from the back corner forward 3. And I'm going to draw a vertical line. How high? 6. Same as the other side. Again, symmetry. So we mark that there. Now, go ahead and clean up the tail on that. So, because it aligns all the way across here, we can test it, and by running our horizontal between this point and this point, we find that it still runs at the 30-degree angle. That means everything is good so far. Okay, all those horizontals are still performing. The angles are get a little funny, but we'll see those in a minute. Okay, so we have a back line here. Let's just connect the dots here to get that roof line to work. And it's not going to be a fixed angle. It's going to be shooting a line between this point, and that's going to get you there. So we put a point at the top and a point down below. And we do the same thing here. That works. Okay, so now that is this line right here. Notice how it's not symmetric, or the view is giving it as uneven lines. Same thing here. So far we're on the right track. We're going to do the same thing over here. Bring our angle and bring our angle back to the back. And that's that piece. You don't see the back one side of it because of the view angle, but it's there. So now all I'm going to do is I'm going to use the same 30-degree angle, and I'm going to project from this corner to this corner to this corner, or straight through from that one beyond. And that is, again, a 30-degree angle. That's that. Okay, so again, distortion, some optical illusion stuff, it doesn't make optical sense, but it is correct. So now I have the form here. We can see it here. We'll erase some of these lines in a minute. And I can see the line going across. Now we need to spruce up some of this here by adding in the front element, this front gable, or this front roof line. So how do we do that? Well, we're going to do the same thing we did before. Remember that it's a horizontal line, so it's going to be at 30 degrees. And how do we find it? We're going to come over to the line. Let's see if I can do it this way. It might be easier for you to see. We know that that's 4. It says that that's 4, and there's a center line, so that's going to give me 2. Same thing that happened right here. And how high is it going to be? It says 5 high. It says 5 units high right there. So I'm going to go vertically 5 high. It's going to create, again, a little bit of an optical illusion. So you got to kind of keep track of your lines here. So I'm going to draw a light line up until it gets to the 5 point right there. Then I'm going to go horizontally back, and I don't know how far yet, but we'll talk about how far back it goes in just a bit. Okay, so far I've got this form. I'm going to go ahead and tighten him up and make him look a little bit easier to recognize. And he's going to go this way back here so we can see that line. This line's going to kind of disappear, so we've got to be a little careful. All right, so we're working on this piece right here, which is this element. We're going to follow the same instructions we did here. We're going to connect from the corner to the ridge on that side. So starting here, we're going to go to the ridge point. Remember, 5 high is that point right there. the other element is almost already drawn for us. There it is. So that's that triangular roof section, which is that piece right there, and an orthographic down here. So now we have that. Now where it gets a little bit interesting here is that, again, going back to our discussion or comment made earlier, that there is a little bit of geometry that occurs in this process. And that geometry is that when we connect a 45-degree angle and another 45-degree angle, and we're seeing it in the orientation, we're going to end up with the same angle canceling out and having a vertical line. So from this corner, extend up, from this corner, extend up to the roof line, and that's going to give you the valley that occurs. That's going to give you this valley right here. Okay, so as a result, this is what we're seeing. We're not seeing the backside. We're not seeing any of this. We're not seeing much of this. So as a result, it's a little bit tricky. I mean, you kind of start to see it as I hold it there, that it kind of runs into a funny set of orientations. And that's what happens with paraline drawings. But we do get a great deal of information from the three-dimensional qualities that it is providing. Now, I'm going to add these lines back in to make sure that they're prominent, and then I'm going to spruce them up a bit with some with some erasing, so that the lines make sense and they'll be more comparable with this line. So the lines that we don't see, that we used as a mark or as a measure, then, and that are not within the view field, we're going to take them away. So I can start to erase them, and you can start to see it become more comparable with this drawing here. If I was using my electric eraser, this would go a little bit faster. But for this exercise, what we've got going is just fine. Now, after we get done with this, you should be able to start seeing the form just a little bit more clearly as represented in our model here. Okay, now, so that's the general form. That's the form there. You have to be thoughtful now. Make sure that you're following the lines that are given in the example here, because what's going to happen is you're going to start to get a little bit of line confusion. I don't want that to mess up your final drawing. So I'm going to go take one more minute, go around this drawing and punch it out a little bit so you can see it just a bit better, and then we'll close this video with some just follow-up notes. So again, these lines seem okay. Again, keep with your 30-degree angles, because that's what the isometric wants us to do. Okay, almost done here. Now, your finished work needs to exhibit all those good line quality things that we talked about beforehand. That's why I suggest do your mock-up here, then trace it perfectly. You won't have all these ghost lines that you're seeing here. Those are very difficult to take off your finish vellum. So, and they'll take points away. We want a nice clean drawing when we're done. That's the drawing. In its rough out, remember, it will be located in the upper portion of the upper right-hand side somewhere. You'll have to kind of look at it graphically to see which one makes sense, but you're going to need to provide a note here. Now it says on the handout that reverse a sample. We're not going to do that. You can just follow the sample pretty readily. But I want you to understand our methodology. We started out with understanding the angles that we were working with and the tools we had, that we were going to lay out the plan first. After we got the plan laid out, we projected up on all the corners. Then we were able to build the roof. After that, then we could clean up some of the background lines and have a finish line representation. And so that's the isometric drawing, and that concludes this portion of this week's videos on Paraline for the isometric drawings. When I see you next, we'll be working on the plan oblique, and that will be in our next video demonstration. So long for now, and we'll see you in a few minutes. Thank you.